Hi all. Today we are starting with new chapter that is push down automata. Now we have already learned what is finite automata or say finite state machine. So push down automata is a similar way to implement a machine where a particular kind of language is accepted. So that language which is accepted by push down automata is nothing but context free languages. So हमने context free grammar देखा है, हमने context free language कैसे है, pumping lemma for CFL CFG हमने already देखा हुआ है. So in this lecture, we are going to study what pushdown automata is exactly and how it works. So if you see, it is similar to the way we designed an finite automata for RL. Pushdown automata is said to be more powerful than FSM. It has more memory than FSM. Why? Because we know that the finite state machine hai, it has only limited amount of memory, because of which there were certain strings which were not accepted by FSM. So to overcome that, now we will design a machine that will be accepting that kind of strings. That machine is nothing but push down automata, because is having more memory. That is, push down automata stores everything in the form of stack. So basically, pushdown automata has the memory of the finite state machine, plus it has an extra memory of the stack. Now, we all are aware of what is a stack because that is what we have studied in data structures. Stack is nothing but a form of data structure that is used for storing particular type of data. So we know that in stack, the data is stored one above the other. The way we say stack of plates, similarly, we store data in the stacked format. So in stack, we perform two types of operations, that is push and pop. Push operation is basically used to insert an element into the stack, whereas pop operation is basically used to remove an element or say delete an element from the stack. Whenever we try to push or pop an element, we always make a use of a pointer which is called as top pointer. So see, this is an example. ये stack है already. I have a, B, and C already pushed into the stack, one above the other. Now let's say there is an element D which I want to push. So what I'll do, first I'll increment this top pointer and then I'll add a new element, that is D. Similarly, now I have to perform a pop operation. Matlab, I want to remove this D from the stack. So what I'll do, I'll first remove that element from the stack and then I'll decrement the pop by 1. So ये रहा, वो D निकल गया, so top is decremented by 1 and now it is pointing to C. Now let's say I want to remove the C as well. So first I'll remove C and I'll decrement top by 1 again. So if you see it clearly, it is shown that whether it is a push operation or a pop operation, top pointer has to be incremented or decremented accordingly. So let's see how this PDA will work. Thus, a PDA has three components. It has an input tape, it has a finite control unit, and it has a stack with infinite size. So this is the input tape जहाँ से ये जो भी string है वो input लेगा. जो जो भी input यहाँ पे आएगा, that is passed on to the finite control unit. So this finite control unit basically accepts an input from this input state. Now, based on the operations to be performed, it will either push elements or say strings onto the stack, or it will pop the elements from the stack. And then based on that, it will be decided whether the string is accepted or rejected. So this is the unit diagram or say block diagram for the push down automata. I hope things are clear by now. Next, we study the graphical notations of what is push down automata denoted. जब हमने finite state machine किया था, we had a simple representation that this is state A, this is state B. So if an input A is there, then it is making a transition from state A to state B. Similarly, in push down automata, we have two states. Sorry, it is over here. We have state A and we have state B. So if an input A is occurring, then what, and if we have a transition or production like this, then what? So ये symbols का मतलब क्या है? The A over here is nothing but an input symbol. So it can be a given symbol, terminal symbol, or it can be epsilon as well. That is, the starting symbol can be empty as well. Of these productions we take, this production means that there is a transition from one state to another on receiving an input symbol based on some conditions. यानी कोई input symbol आ रहा है but उसके साथ कोई particular condition attached है. So when I say B gives C, यहाँ पे इसका मतलब क्या होता है that this symbol is on the top of the stack. So always if you have the production like this, it means it is on the top of the stack और ये element हमेशा pop करना होता है. यहाँ पे जरूरी नहीं है कि टर्मिनल सिंबल्स ही हो, you can also have epsilon. If you have epsilon at this place, it means that nothing is read or say nothing is popped. Similarly, if you have symbol on this side, it means that this element has to be pushed onto the stack. That is, you're performing a push operation. So yeah, ये element is to be popped. This element is always to be pushed. If you have epsilon on this side of the production, it means that there is nothing to push onto the stack. So I hope I have made things clear by now. इसके related one more reference video I'm going to send. Please watch that carefully. We'll be starting with examples and sums in the next video. Till then, please go through these definitions and the graphical notations properly. In case of doubts, please let me know. Thank you.